we're finding all of those things. I'm just going to kind of organize it on the side a little bit better for you. But this is what your take home test will look like. Yeah. So from f of x, you can find out if there are vertical asymptotes or horizontal asymptotes. Starting that's from the limits here. Remember, vertical asymptotes happen when the bottom is 0, but the top is not. So what x value make the bottom 0 here? 2, and does 2 make the top 0? It does not. So then we have a vertical asymptote at x equals 2. And I can put that on my graph. Start the graph process. So this is where it comes from. So it's like bottom equals 0, top not equal. The horizontal asymptote is where you're looking for the higher power. That thing. So there's a higher power on top, bottom, or tied in this one. It's tied because you got x to the first, that -2 doesn't matter. And basically you cross off the tie, and the coefficients that are left over is your horizontal asymptote. So at y equals -2, there's a horizontal asymptote. So remember, can I cross through a vertical asymptote? No, but can I cross through a horizontal? Could. I don't know if I will, but it's possible that this goes like this, and then like levels off here, levels off this way. So it doesn't mean you will cross the horizontal, but it's possible. Okay, from f prime of x. First of all, I'm going to say like what is f prime of x, and then also from that we're going to learn increasing, decreasing, relative max, relative min. -2x over x minus 2. So I don't have an issue with quotient rule here. You're not going to have to. You want a fraction anyways at the end, because at the top and the bottom is 0, so it's not going to quotient rule fraction. That's fine. You could do like bring this up and do product rule and chain rule. I'm going to do quotient. So we go to the bottom. Times the derivative of the top, which is -2, minus the top times the derivative of the bottom, which is 1, over the bottom square. If I try to clean up that stuff, I'm trying to save space, we still got to do like the second derivative. Plus 4 plus 2x, which is 4 over x minus 2. Agree? So now we do our process. We're going to take the top, set it equals 0, take the bottom, set it equals 0, make our intervals and stuff like this. So if I set the top equals 0, nothing happens, right? 4 never equals 0. This one, if I set it equals 0, what would I get? I get x equals 2, right? So then if you want to think about a number line, or draw a number line, you can do that. You don't necessarily have to. So I'm going to skip to just like what the intervals are. And if the number line helps you see that, then like the number line is what it is. So now I'm working in the first derivative. What does the first derivative tell me about? Slope, increasing, decreasing. And that's what I'm supposed to find over here. So where's the function increasing and decreasing? So I'm going to pick a point from, here's what I'm trying to get you. You always plug back into the level that you're at. So if I'm on the first derivative, I'm going to pick a representative point and plug it into the first derivative. So that'll tell me increasing. From the second derivative, I'm going to pick a point and plug it into the second derivative. And that would tell me like that. So wherever you're we're done with the first derivative. All right, then we're gonna find the second derivative. I have to find out where the function is coming from. Point of inflection. How would you feel if we just kind of cheated and calculated the second derivative? I'm just well out of room, so I'm just gonna throw in here. So my second derivative is negative 8 over. Hold on. I typed something wrong. That might not be right. Yeah, okay, over x minus 2. So I would just do both of those again. I'm just trying to save space and time. Are we all, I assume we're comfortable taking that derivative? So I get to here, so it's like, okay, now what do I do? We're going to do the exact same process that we just did the first derivative, but we're going to do it the second derivative, we did yesterday. So set the top of bottom equal to 0. Set the top equal to 0, that's useless. Setting the bottom equal to 0 gives us x equals 2. So then I'm working with my double prime now, but my critical point is still 2. I still build my intervals around 2. And remember, you plug back into the level that you're working with. I'm working with the second derivative right now. So I'm going to pick points between these regions and plug into the second derivative. The second derivative tells me to kind of cap. So if I plug in like 0 to the second derivative to this, the top and bottom will both be negative. We'll end up with 0. It'll be a positive number. So y double prime is positive, which means y is concave up. I don't know what's that. To infinity, let's say I pick 10, that'll give me a negative number on top, and if I look at 10, that'll give me a positive number on the bottom. Negative plus positive is negative, so y double prime is negative, which means y is concave down. So it appears like we have, so what this means right now is we have a potential point of inflection. It looks, so I did switch, right? I switched concavity, I went up and down. But it's only a point of inflection at this actual coordinate. So I can kind of try to start that at 2 comma what? But if I plug 2 into the original, what am I going to get? Maybe undefined, and there's a reason for that, because what is x equals 2 already been included? It's vertical asymptote, so there is no point of inflection. Okay. So that's kind of a summary of what we have. I'm gonna write down some notes. I don't have a magic idea for where you should put this. But see what I'm writing. Decide from there where we go. What's not very? Okay. So graphs are compromised in basically 4 shapes. Well, 5, I guess it could be a line too. All right, so the graph f of x might have this shape. F of x might have that shape. F of x might have that shape. F of x might have that shape. Basically, every graph you see is comprised of those for each one of these, we need to understand what is true about the derivative and what is true about the second. So this guy is increasing, right? Which means the first derivative is positive. Also, what do we know about that concave? Concave down, we're making that head, right? So that double prime of x is negative, which means f is concave. Then I can go through and do that for each of these shapes. So for this guy, is f prime positive or negative? Negative, because f is decreasing. F double prime positive or negative? Also negative. Why? What did you say to me? You said the IT word? Wait, what? We have a word for that. In other words, starts with C. Concave down. Yeah. You're right. We're all saying the same thing. Alright, so I go to the next one. F prime in this one is negative because f is decreasing. But f double prime here is positive, isn't it? Because that's making a U. Looking like a concave up. So f is concave up. And then for this one, f prime would be positive because f is increasing. And f double prime would be positive because f is concave up. I should have written an f here by increasing and concave down there. But basically, those were things. So those are like just the way we're going to combine things is with those shapes. Find a spot to write them down. Somewhere if there's a spot nearby. Where am I going? Take picture of this. Anybody need more time to get this? Definitely gonna want. Okay. So let's go back to our example here. I'm gonna make a number line. I'm jamming in here a lot. I'm make a number line down here. I'm gonna put any critical point that I saw from either line. So the first derivative, I had a critical point of 2. The second derivative, I had a critical point of 2. That's the only one I had. So I'm just gonna put a number line. That splits it into like less than 2. 3. So now on the top of this number line, I'm gonna put whether the original function is increasing. So over here, when I'm less than 2, based on our work above, is f increasing or decreasing? Increasing. It's increasing the whole time, right? We got anything. And on the bottom, I'm gonna put whether f is concave up or concave down. So down here to the left of 2, I concave up or concave down. Left of 2, negative 2, concave up. And then to the right of 2, 2 to 50 is concave down. Now can you take increasing concave up and draw one of just draw like right here? Can you draw the shape that goes with like increasing and concave? That guy, right? But increasing concave down. That guy. So those are the two shapes we have to put on the graph. And if there were points that we knew, like if we had a relative max or a point of inflection, we would have to worry about those. I don't have any points. All I have. Yes. Do I get all 3 of these? Who's the side of your work, and I would, on the side over here, and I would see that you did. I would check all of those things. It'd be like a 10-point question. You got one right, you 10 out of 10. If you didn't, I'll start looking like, okay, where did I mess up? Can I get partial credit for this? Questions on that process? All right, let's do another. What? You still can show up. Let's look at 4. Okay, well now I'm looking at your work, man. I will not look at your work unless you're eliminated. The fine-tooth comb. Alright. Flex tells us about vertical asymptotes and horizontal asymptotes. On your test, I'll just have this like pre-written for all the questions. That helps me because I don't know there is not. There are no asymptotes in this one. How do I know? Not a fraction. Not a fraction. There cannot be asymptotes. Alright, so then we go to f prime of x, which thankfully this one is quite a bit easier than the last one. Negative 3x squared plus 6x. I'm going to use that to find out 4 things from the first derivative. I can tell where things are increasing, decreasing. I can identify a relative max, a potential, and a relative. So I know f prime is the negative 3x squared plus 6x. My job is to set the top and bottom of that equals 0. The bottom, right? So I just set the top equals 0. Don't subtract 6x from both sides. You'll end up canceling an x out and you'll lose an in. Instead of moving the 6x over, what can I do? Everything on this side. I can factor. So you can factor negative 3x or 3x. That's negative 3x, I can x minus 2 on the inside. If you did 3x, you know. Oh, it's okay. No, it's right. I was just, something else was messing me up. Alright, so set that equals 0. Get x equals 0. Set that equals 0. Then get x equals 2. But if you had subtracted 6x and then canceled the x, you just like eliminated that x equals 0 and given x. So factoring is better than that. So that tells me like where to put my intervals. I'm gonna build around those 2 points. That really helps. And then I plug back into the level I'm at. Right? Whatever level you're working with, that's where you plug in. So I'm gonna plug in like negative 10. And I'm gonna think about plugging into this. See, that's easier. That's positive. That's negative. Positive times negative is negative. So f prime is negative, which means f is decreasing. See my finger? Oh, I'm fine. So plug in something between 0 and 2, so put the 1, let's say. This bit would be negative, this bit would also be negative. So negative divided by negative makes f prime positive. That is increasing. And then that last part, so if I plug in like 10, I have a negative number. So the last time we didn't have any like max or mins, because nothing switched, but we do have some things switching here, and there's no acid tests. So they're going to be legitimate max and mins. So at x equals 0, prior to that I was decreasing, after that I was increasing. That means there's a relative min at 0 comma something right here. And how do I find out the something where I'm measuring that? Original equation. I want a y value. So if I put 0 there, I get 0, and I can actually put that point on my graph. A legitimate point on my graph. Right here. Let's try again. Wait, at x equals 2, what do we have? We have a relative max, don't we? Because we're going from increasing to decreasing. So that's at 2 comma. Plug in the original, find that out. So it's negative 8 plus 4. So at 2 comma 4, that's another like actual legitimate point I can put on my. So I've done my first derivative stuff. I'm ready to move on to my second derivative. Up and down, and then points to the top. Okay, what's the second derivative? Negative 6x. Your job is to set the top and bottom of that plus 6. Plus 6. Thank you. Your job is to set the top and bottom of that equals 0. There's no bottom. We're just going to set the top. 6x equals -6, and x equals 6. So that gives us like the point of the number line that we build around. So we'll go to negative infinity, 1, 1 to infinity. And you plug back into where you're working. So since I'm on the second derivative, I plug back into that second derivative level. And that's going to tell me concavity. Second derivative is always concavity. So if I plug in like 0, -6 times 0 plus 6. This would mean f double prime is positive. F is going to be up. That means up, -4. Thanks. Have a good no, that's it. Plug in like 10. If I plug in 10, the second derivative is going to be negative, which means we are trending down from 1 to infinity. So we do have a switch to the third point of inflection. It is. This is kind of weird the way these are written. Like this is an interval, right? It's like between negative infinity and 1. This is an interval. It's like between 1 and infinity. This is an actual point. They're all written the same, so it's kind of looks confusing. So I'm just making sure we understand. This is like an x and y value. These are intervals. So how do I find the y value that goes with x equals 1? Plug into the original. That'll give me 2. That is another point. What's wrong, Max? Oh. 3 points. Looks like a line. 5.4 basically, and this was 5.6. Asymptotes were like 2.4, so there's like 3 different views. I'm gonna make my like summary number line. So any critical point that I saw from any level goes up. 0, 2, and 1. Put in order. Top of the number line, I'm going to go through and write down whether the graph is whether FMX is increasing or decreasing. So from 0 to 2, it's increasing. FMX is increasing, which means both of those intervals. We'll get that because it's from 0 to 2. Decreasing from negative infinity to 0, so decreasing over here. And then also decreasing from 2 to infinity, so decreasing there. And we had our relative max and min at like these 2 spots. And there's not one at that spot. You can tell it's because of the switch. Bottom, we're going to do concavity. So I learned up here that we're going to get down all the way up to 1. So any interval that's to the left of 1, I'm just putting concave down. And then from 1 to I did that backwards. This is up. So that's concave up. That's how I was supposed to up. And then concave down from 1 to infinity. So in these 2 spots, concave down. That's what X. Sorry. That's going to be concave down. So now, see if you can put those shapes on those 4 sections. Decreasing concave down. Downward part of the head. So, concave up. How do I do down so high? Decreasing concave up looks like that. Increasing concave up looks like that. And you can almost like see on the graph, increasing concave down looks like that. Decreasing concave down looks like that. So you kind of see the shape that you're going to make, right? But you got to make it through the points that we have. So our first like 4 sections, to the left of this dot, between these 2 dots, and to the right of that dot. The very left hand section is supposed to look like that. And then this shape down here. I'm just transforming it. Some people, I'll wait for you to show. The next section is like the second half of a U, up, it's curving upwards up until there. And then that's a point of inflection. So it kind of starts curving back. And then this last part is down. So first of all, questions on what I did there. So what I want to make sure of is you understand like how I grade these. There is no way that you have to tell whether this shape is how it looks, how I drew it. Maybe it's like this, or maybe it's like this. You can't tell. I can't mark any of those wrong. It's pretty hard to do something different in here because there's not that much room. But I mean, this could go like a little steeper. It could go a little flatter. This might go like that. This might go like way over there. It might do what I did. I can't mark any of those wrong as long as you have the proper shape in each one of those 4 slots. What I can mark wrong and what people screw up is you try to get fancy. I don't know if it's like an artistic thing. You guys want to be like artists, but people will do this. So you just put a whole other like concavity shape in there, right? Just because you want it to look prettier. I don't know. Same thing over here. People will go, oh, let me out. But like that extra bit makes it wrong. So don't do like an extra bit. Questions on that one? You can see why I'm taking it. Let's have you guys try one. And then we'll check it before we leave. Let's say, do 3. Answers are attached.